Welcome to the fourth lecture on business process mining. In today's lecture, we are going to look at automated process discovery, and more specifically, we are going to look at how those process maps are actually created, what are the drawbacks of those process maps, and how to overcome those drawbacks. After that, I am also going to give you an overview of how I would approach the analysis of an unknown event log using the techniques of automated process discovery. But to begin with, let's remind ourselves, how does automated process discovery work? So at the beginning, we have an event log, and based on that event log, we can get either a process map or a PPMN process model. Now, we have already looked at the process map before. However, I'm going to give you a short overview of how the process map actually works, how it's going to be built, and from that, I'm going to also motivate why we need the PPMN process models as well. So to begin with, a process map, as we remember from the previous lectures, is a graph where each activity is represented by one node. An arc from an activity A to activity B means that B is directly followed by A in at least one case in the log. We also remember the main elements of a process map. We have initial activities, directly follows relations between two activities, eventually follows relations between two activities, which are not visualized on the map actually. Then we have activities themselves, activity self-loops, which indicate reworks usually, short loops, which can be reworks, and final activities. Now note that process maps are very easy to understand, but they can be misleading. And actually they have quite some nasty drawbacks, but in order to explain those, I have to give you an overview of how a process map is built. So let's take an example. Let's say that I have an event log with 5 case variants. The numbers in front of those case variants, those are going to show the frequencies of those variants. And let's try to build a process map for it. If we begin with the first trace, then the process map is going to be quite obviously just a straight line, A, B, C, G, E, H, and that's our process map for the first case variant. Additionally, we are going to add the case frequencies onto the arcs, and we are done for this case variant. If we take the next one, then the first 3 events are the same as we had before, so A, B, C. After that, we see a new event or a new activity, F. So we add this to the process map, we add the frequencies to the arcs, and then we look at what is the next event. The next event in this case is G. So we already see that G is in our map. We are going to go back to the original node that we have, and from there we see that the next event is H. So we go from G to H and add a new arc. We follow the same procedure for the next case variant, introducing the node for the event D, and then finally one more, or the final case variant, introducing one more arc into the process map. And the last step is to just sum up the case frequency numbers, and this is going to give us the final process map that we have. Now I hope that everyone who followed it agrees that I didn't make any mistakes. At the very least, by the way that the arcs were created into the process map. The reason why it's important that we all agree on this is because if we look at this process map in practice, we can notice that it's kind of going to detect some traces that didn't really exist in our event log. For example, A, B, D, E, H. This does not exist in our event log. In fact, all of the traces or case variants in our event log have 5 or 6 events. Meanwhile, this path through the process map has only 5 events. So this is already one place where your process map can mislead you. Another one, you can see that there is a back and forth between G and E. And now, if I were to follow this process map from start to end, from A to H, then I could repeat that loop as many times as I want and essentially create an indefinite number of traces. And now this is kind of what is the problem with our process maps and that we have to be aware of. I will show you also a demo where I'm going to show you a practical example where this becomes a bit tricky. So let's take a look at treatment process of sepsis cases in a hospital. To start with, I'm going to add a bit more arcs than we have by the default settings in order to make the process map a bit more interesting. So if we look at the beginning of the process map, it is quite clear what is happening. ER registration, followed by ER triage, followed by ER sepsis triage. There are, of course, some numbers or some cases missing from the process map, but this is just because of the abstraction settings that we have. If we go further, then the real decision point we can see after IV antibiotics. We have admission NC or admission IC. Looking at the names, I think it's quite reasonable to assume that you are going to do either admission into IC, intensive care, or admission into NC, non-intensive care. But once we go further than that, then there is another place where we have laxidic acid, leukocytes, and CRP. And there is quite a bit of back and forth between those. And it also seems kind of like there might be a loop here, because you could go laxidic acid, leukocytes, CRP, back to laxidic acid, and continue like this in the loop. Now, is that really the case? Because this kind of look like medical tests. And perhaps it is the case that those medical tests can be done in any order, and maybe they can even be done in parallel. And this is something that we can't really say based on this process map. We can see the sequences of events, but we can't really see if there is any parallelism here or not. And in order to figure out what is actually happening, it is very beneficial to take a look at the PPMN model that we will be covering in the next part of the lecture.